this section, distance and midpoint formulas, and then also the formula for circles. I think one of the really cool aspects of mathematics is this question of the distance will follow you for a very long time. That distance concept is what makes up a lot of what we call engineering science, approximation theory, in terms of trying to measure. And what that entails is so explosive in terms of how far the advancement in technology has come in measuring distances. Sometimes distances that is difficult to either get to, or this idea of a distance that seems to be fuzzy. We talk about straight lines, and so you measure a straight line, but sometimes the distances tend to go around curves, and so how do you measure that as well? But here we restrict our discussion to just this distance with respect to a line based on 2 points, and then by that we should be able to cut it in half and get the midpoint, and then we will conclude with the circle, and then we look at the circle in 2 ways. One, we'll somewhat give you the equation that's already in standard form, and then we'll ask you to, from it, extract the center and the radii, and then we can flip it around where we can give you just this general form of the equation, and then from there complete the square, and by that being able to determine therefore the center and the radius. So let's look. So first, the distance formula. We have 2 points in the Euclidean plane of x, y. So from there, we should be able to find the distance between those 2 points based on this this so-called norm or magnitude. So say, for example, let V equal to this point, say x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. Then the magnitude of V is given by this norm of V, which is the same thing as this formula for the distance. So this is a different way of writing it. You see that a lot when you look at things like in Calculus 3 and also in linear algebra, where we deal with this idea of the distance or the magnitude or the norm. We'll take that formula and just find the distance between 2 points. And so we're given 2 points. Just use the formula to find the distance. Let's see. So here, find the distance between these pair of points. And by using that formula, we have the distance is equal to, so this would be x sub 1 and y sub 1, and this is x sub 2 and y sub 2. So the distance is the square root of the x sub 2 minus the x sub 1 to be squared, plus the y sub 2 minus the y sub 1 to be squared. So this is the square root of here. This is 8 minus 6. And you could just simplify that. I'm just writing everything out. Then plus 5 minus 3. Well, we simplify that. And so this is 2 to be squared, which is 4, plus 2 to be squared, which is 4. So we get 8, or 2 times the square root of 2. And so we're going to put that number here. So the distance between, well, that number doesn't go down, I'm sorry. That number goes up here. It's 2 times the square root of 2. And so since this answer involves a radical, then we just use a calculator and get that number. I don't have a calculator up here. Well, in my math lab, you get that number just on your calculator, and it says to round that by 2 decimal places, and so you'll put that answer here. Does anybody have a calculator? I didn't bring my phone. If I had my phone, I could compute it on the phone as well. Anybody get it?
2483.
That's 2 times the square root of 2. You get 2.83. Okay. Thank you, ma'am. Appreciate that. The midpoint formula, again, given 2 points, obviously the midpoint would be just to take the coordinates and just divide by 2, and that's exactly what we do. The sum of the coordinate length. So here the midpoint would be this -2 plus a -5 divided by 2. Comma, -6 plus a -5 divided by 2. And so this is -7 over 2, comma, -11 over 2. So that's it. Okay, for the circle, the cool thing is that we have the formula for the circle, and this formula simply says that a circle has this standard form where h comma k is said to be the center, and then the radius is given by r, so we have x minus h to be squared plus the expression y minus k to be squared is equal to r squared. So you want to pay attention to how the formula is written, especially to these signs here. The formula says that the expression has to be of that form. So if it's x plus 2 to be squared, then you know that h is going to be -2. if we have x plus 2 to be squared plus, say, y plus 5 to be squared is equal to 16. So this is understood to be x minus a negative 2 to be squared plus y minus a negative 5 to be squared is equal to 4 squared. And so then this implies then that the center is negative 2 comma negative 5 and the radius is 4. See, that is x plus 2, but that's the same as x minus the minus 2 because the formula calls for, I have to have that negative there because that's what the formula is giving me. Right? And in another sense, and it would be interesting to see the correlation between the distance formula and this equation here, and all the equations that we get for the conic section. We have the ellipse, the hyperbola, and then the circle, and then the distance formula itself. There's a correlation with all of them. So here, they want us to find the standard form. Again, the standard form is this. We can get that if we're given the center and the radius. Right? So that's the cool thing there. So here the standard form becomes x minus 4 to be squared plus y, that's plus 5, right? Y minus a negative 5 to be squared is equal to 2 squared, 4. So you're going to enter that there in my math lab. Okay. So here, give the center and the radius, and then also from their graph this equation. So what's the center? It's your turn to talk. What is the center? Do you see it? Well, what's the radius? Is it 4? The radius is r squared. So what's the radius? 7, right? You got to remember the formula. The formula is x minus h to be squared plus y minus k to be squared is equal to r squared. So what's h, what's k, what's r? Do you see h and k? Can you say no? Can you say no? Say no. Say no. Good, thank you. You don't, because we can't see 0, right? Isn't this x minus 0 to be squared plus y minus 0 to be squared is equal to 7 squared? So it means that the radius is 7, but the center is 0, 0. Because x minus 0 is just x, right? And y minus 0 is just y. Does that make sense? Okay. So the center is at the origin, and then we go out to 7, and then you just draw your circle. So what about this one? What's the center for this equation? -1, what else? 5. Good. And the radius? 3. And so to graph that, so we're going to find the center, that -1, comma 5, and then the radius 3. So we find -1 for x, and then we're going to go up to 5. Looks like the center is there. And then I'm going to just go up. You're going to pick this guy here, right, for the circle. And then I'm going to go up 1, 2, 3, the radius, if you will. Go down from there, 1, 2, 3 here, 1, 2, 3 there, 1, 2, 3, and then now it says to express the domain in the range. So the domain are the x values that define the graph or the function, and then the range would be the y values that define the graph or the function. So my domain is going to run with respect to the x values. The furthest value x to the left, the furthest value of x to the y. So that looks like this guy here is -4. And then this looks like 1, 2, 1, 2. So the domain would go from, that's a bracket because this circle includes these points. So -4 all the way to 2. Now for the range, I'm looking up and down. I'm looking this way, the furthest point up and then the furthest point down. So this was 1, 2, that's 3 for y, and then this is 6, 7, 8, 9. So the range values would go from 3 to 9. Does that make sense? Again, the domain or the x values that define the graph. Where's the graph? Look at the x values with respect to the graph. That's my domain. The range, look at the graph, and then look at the y values. That gives me that graph. And that's how I get the range. And then the last part in this section is they give the general form of the equation of a circle, and then they want us to, from there, extract or to produce the standard form. It's pretty interesting how they use, this terminology in math, in every discipline, every subject. Even when you get on a job, they have their own terminology. You have to kind of learn, their system if you want to succeed in that. The same thing here, and that's the goal. Look, folks, that's the overarching, the main goal to education is just learning, adapting to a particular system, and then based on those rules and properties of that system, you're able to maximize that is succeed in producing the outcome that is desired. So then, if you do that well in college, then what we're saying is you have the aptitude to take any job, any career, and do the same thing. The question is whether it's this class, mathematics, or a history, or a literature class, or whatever it may be, and then students tend to deal with the questions in their head. Will I ever see this stuff again? Will I ever use this stuff again? Probably not. But that's not the point. And so don't get bogged down in the mud without understanding the whole purpose of why you're here. The purpose is, given a different set of rules and circumstances, can you learn those properties, fulfill the outcome, the desired outcome, with what's being asked for here, so that when you go to other situations in life, it's the same scenario. It may not be X's and Y's, but it's going to be something that's different, something that's foreign to you. But that's okay. If they give you a manual, study it. You can't argue, one, I haven't seen this stuff before. That's what you said in college, but you've gotten over that. You can't use that argument that I haven't seen it before. Most things in life you will not have seen before. That's the reason why we learn. The other argument that you can't use is just not that I haven't seen it before, but you can't use the argument that I don't know what to do. God gives us a brain so that we can read and think, apply those critical skills to anything in life, and you'll succeed. Who were the first computer scientists? Does anybody know? They were mathematicians. Because at that particular time, there were no computers. So who was going to write the code? Who was going to formulate the concept? So the concepts in computer science, computer engineering, is based on what we call Boolean algebra, Boolean mathematics, which is one hierarchical plane stemming from linear algebra. It's a series of zeros and ones with computation within matrix algebra. And putting these strings of zeros and ones together, you can produce characters, numbers, digits, letters. From there, a syntax. You can bring them together. You can form words, form statements. And then from there, argument. So if you take C++, Pascal, any of the computer languages, you'll realize that they're all based on mathematical logic. That all comes from here. And then it's applied elsewhere. So when I was in graduate school, when I was an undergraduate, I learned Pascal, basic, in middle school and that kind of thing. But in college, it was basically Pascal and C++. So when I took a course in applied mathematics in graduate school, numerical analysis, the whole course was based on Fortran. Well, I'd never learned Fortran before. I couldn't say that to the professor. Now, you're here to work on your master's PhD. This is mathematics. You don't say, I don't know that. You've been taught the skills to learn anything in life. So I went back to my apartment and into the computer lab, and just within one day, I learned Fortran so that I could succeed in that particular class. So, given something different, given something new, what do you do? Do you back up or do you go forward? I think you have what it takes to succeed. So to be able to take this equation in the general form and then to write it in the standard form, what's the standard form? I want to be able to produce x minus h to be squared plus y minus k to be squared is equal to r squared. So here you go from the general form to the so-called standard form. Now to get the standard form, we have to complete the square. Okay. Let's see. So the steps for completing the square on x squared plus bx plus c equal to 0. We're going to get that c term, that's that number, that constant out there by itself, get that on the other side of the equation. And then after you do that, whatever that term that's multiplied to x, that's called the coefficient of x, that's that b term, you're going to take half of that. And then when you get half of that, you're going to square it. So say, for example, if b is, let's say it's 10. So I'm going to take half of 10, I get 5. Then I'm going to square it, I get 25. Then I'm going to add 25 to both sides of the equation. What you're doing is you're forcing this x squared plus bx plus c, you're forcing it to be a perfect square trinomial. So the idea of terminology we say is you're completing the square. I'm getting the square. And how do we get it? Is the most one of the most important concepts in mathematics. I deal with what's called the sophisticated zero. I can take 0, which is a basic property in set theory. 0 can be added to any term. A plus 0 is equal to A. So this idea of taking the coefficient of x, taking half of it, squaring it, and then I'm adding it to both sides of the equation. Well, if I'm adding to the other side of the equation, I'm actually adding it and subtracting it right where it is. So I have this squared nature. Say, for example, this number, let's say it's 64. I'm actually doing plus 64 minus 64, which is still 0. That's important. So don't underestimate 0. Now, you can factor the trinomial, which is now a perfect square. Let's see. Now we have to do that not just for the x squared, but also for the y squared, because I have a y squared there too, right? Is x squared? Let's regroup. So this is x squared minus 4x, putting the x's together. Plus, basically, I'm putting the football guys together and then the basketball guys together, right? So here are the basketball guys. So you get that minus 16. That's that c term. I'm just going to add it, get it to the other side. So this is equal to 16. So I have x squared minus 4x. I'm going to start there. So completing the square, it says, look at the coefficient of x, which is negative 4. Take half of it, I get negative 2. Square negative 2, that gives me 4. So I'm going to add 4 here. I'm going to put this equal sign right there. It's at 16 there. And then I'm going to add 4 on the other side. Now, remember, we got this plus y squared minus 8y. So now if I look at the coefficient of y, it's negative 8. Take half of negative 8, I get negative 4. Square negative 4, I get 16. So I'm going to add 16 to both sides. Plus 16 plus 16. So now what you've done is to force this to be a perfect square trinomial, and you force this to be a perfect square trinomial. So let's see. Isn't this just x minus 2 to be squared? Plus, isn't this just y minus 4 to be squared? Let's simplify this. This is 36. But isn't that 36 the same thing as 6 to be squared? So what we have, yes, is x minus 2 to be squared plus y minus 4 to be squared is equal to 6 squared. So we've gone from this general form to the standard form by completing the square. Here's my question. Did you see the power of adding 0? Did you see it? And you probably didn't. And just, we can tell the truth here. You probably didn't see it. I want to show you. Okay, I want you to see it. So what am I saying? My argument here is that we have not harmed this problem. It's still intact. It's just in a different form. Let me show you. So this is the x squared. I'm going to show you, this is Macbeth's soliloquy. This is something on the aside. We're just thinking. So this is the x squared minus the 4x, and then that was the plus y squared minus the 8y minus 16 equals 0. That's the original problem. So this is x squared minus 4x. We took the coefficient of x, which is negative 4. We took half of it. We get negative 2. We square it. We get 4. So basically, I'm adding 4 and subtracting 4 right where it is. Plus y squared minus 8y. We took the negative 8. Take half of that. I get negative 4. I square that, I get 16. So I'm adding 16 and subtracting 16. Then we got that minus 16 right there is equal to 0. What I want you to see is that this is 0. That's 0. I mean, don't go back to the next line and put 0 there because you're just going back. I mean, you did that for a reason, right? I mean, if you go back and write a 0, then you hadn't gotten anywhere. You've only accomplished what Maxwell said, Lord Calvin, and that is that energy is conserved in a particular unit, and it remains to be 0. You'll get that in Calculus 3, differential equations, and then also in physics. So now, this is the perfect square trinomial. That's the perfect square trinomial. That minus 4, we add to both sides, and that's how we pick up the plus 4 over here. And we add this 16 to the other side, and that's how we get the plus 16 over there. So this is x minus 2 to be squared plus y minus 4 to be squared. And then I'm going to take this term, and that term to the other side. So this becomes equal to a 4 plus 16 plus 16. I just want you to see the 0. We've added and subtracted, so I did not harm the problem. All we've done was just to rearrange, which is the case in terms of what man does anyway. He just rearranges. Then from there you want to graph that. So the center, go back and look at what we have. So the center is the 2, 4, and the radius is 6. And so we graph, we find 2, 4, x equal to 2, y equal to 4. That's the center. And then we're going to count out from the center 6 units. 1, 2, 3, 4, 5, 6. And then we're going to just draw that circle about that, right? Okay, it's drawn by hand, right? So more accurate on the computer. All right, let's see. So here was the graph that I did, and then also this one. And look at both of these, because one of them was not correct. We'll go back to this one. You see that one? And then this one. Which one is correct and which one is not? Were you able to pick it out?
I think the bottom one's correct.
When you say the bottom one, I'm sorry. It's just one here and then this one there. Which one do you mean?
The first one you had up there.
So is this one?
I'm saying that one's incorrect.
This is incorrect?
Yeah.
Okay, and why do you say that?
I feel like it's incorrect.
The radius is 7.
That's right. You see that the radius here is not 6. Let's count down. 1, 2, 3, 4, 5, 6, 7. All right. Okay. And then you go to this one. 1, 2, 3, 4, 5, 6. Okay. Yeah. Very good.